Good morning, for science one. Okay.
Morning, teacher.
Yeah, good morning, everyone, for science one. Okay, nice to meet everyone again for this second lesson of the week. Okay. So there are few more students now waiting for them to come in. Okay. I hope they will come in now. I hope they should come. Okay. Okay, before I start the lessons, I will like to tell you all something regarding your work to pass up one the folder. Okay, actually I already marked your folder, almost I finished mark already. There are few students, sorry to say that you don't achieve the targets I want. You know why? First is because you did not finish all the work. Even the example I see, when you pass up your paper, the example also blank, you don't write anything. This kind of quality doesn't reflect you are in 4 science 1, Okay. 4 science 1, I expect much better than the quality of the work you pass up to me. Okay. So I have to name a few okay. Actually, I'm quite disappointed, this first one I realized is this who already. Choi Zikai, your work is incomplete. A lot of work you did not finish, Choi, sorry to say that I have to call your name. Joshua, another one. Joshua, incomplete works. A lot of example, blank, no answer. Okay. There are a few more now. I will take a pictures of your work that I will put in the group. Let you all see yourself. This kind of qualities doesn't reflect your in 4 science 1, Okay, first time you pass up your work, you give me a very bad impression, Okay, 4 science 1, sorry. Okay, compared to 5 science 1. 5 science 1 works, they have better quality, all the work finished one. And this 4 science 1, I've been reminding you many, many times, right? Giving you the paper, you print out the paper, all the example, the notes, the solution, you must complete before you pass up. Okay? And some of you, I see your paper, right? The objective question, for example, there's no solution you show. You only circle the answer, you pass up for what? And most of the questions are already explained to you. I show to you the solution, the working, how to get the answer. I don't believe they are that magic, You never show any working straight away, you circle the answer. So this is the first time, okay? So of course, this few students, I will give you very bad, very low marks. Okay? So this is the first warning I give to 4 science 1. Actually, I expect much better than this time, Okay? So remember, I don't want to do your work, you pass up the work in such quality, Not finished work, no solution, just to circle the answer for what? The solution already I explained step by step during the class. You did not copy. Then you just circle the answer, you pass up. So please remember what I reminded you this time, okay? So please don't repeat again, 4 science 1. Okay, of course, they are most students that pass up the work with very good quality. Yes, I know. I noticed that many of them, their works, they finish up everything. Example, everything copy, solution for all the question, show your working, everything got. Okay, majority are good lah. Only because of few person make me very upset. Okay, yesterday I was in school, the whole morning I marked your paper. Okay, I feel very disappointed, because of just a few of you lah, Joshua, Choi, 2 of you, okay, so please And second things, one more things I want to remind you all is your handwriting. The handwriting is not good, Okay, so far I marked so many, only a few, handful of you, the handwriting very neat, very good. Okay, for example, I take one example, Teo Shiming. Teo Shiming, I don't know who is this girl, but I know her work is perfectly done. Very good. Very neat. Okay. Very neat. Everything. The handwriting, very good. Everything complete. Okay. Right, for science 1, okay, remember, no. So please lah, you must produce work reflecting your position in the school. You are in 4 science 1. Cannot do work simply. Okay, your handwriting also, you didn't write properly. Another one is Andrew Day, also the same. Okay, Andrew Day. Okay. All right, so we start our lesson this morning. Okay, I hope what I say just now, you all take it. Okay, take it seriously. So make sure you do your work properly. Finish up all your work. Okay, when I say ask you to pass up, complete everything. And one more thing, sir, I inform you to pass up 2 set of paper only. Some of you, I see the chapter 2 you also put inside the folder. Then now I'm talking about chapter 2, you don't have the paper. So how? You all never listen to the instruction, you know. I say pass up 1.1, introduction to physics, and then 1.2 is the scientific investigation. That's all. Chapter 2 paper, you don't pass up, you still need it now. And then you go and pass up. Simple things, this is simple instruction that you all cannot understand. Okay? There are a few of them, pass up all the paper given. Okay, never follow, never listen to my instruction for science 1. Okay? I say pass up 2 set only, you pass up 2 set now. The one just newly given to you, you put there, then all kosong, blank, then you go and put in the folder, you pass up. And now I'm talking and using the paper, then you say you don't have the paper with you. You say I already pass up. I never asked you to pass up. Okay? Okay, for science 1, Okay. So I start this morning's lesson. This is the first time, I scold for science 1, never happened before. I don't know what happened when you are in Form 3, okay? When you come to Form 4, you never show your quality. All right, this morning we start lesson 2, okay? Lesson 2. Chapter 2, lesson 2, okay? We have lesson 1, you have finished already, correct or not? Marcus, can you check for me? Lesson 2, chapter 2, lesson 1, finish or not? Liu Jiajin, can you check? Chapter 2, lesson 1. Have we finished? Finished already, So now we start lesson 2 of chapter 2. Yes, when I remember you, Liu Jiajin, you also one of them, incomplete words. You never finish your work. Okay, Jiajin, sorry, I had to mention your name.
Okay.
You pass up, then you never finish your work. Just pass up like that. No, cannot. Don't do that. Okay, come. In this morning, lesson 2, what you're going to study is motion graph. So it's on graph you're going to study. Okay, so I want to start with 2 graphs, at the same time. Okay, come, let's look at this. One moment. There are 2 graphs here you are going to study this morning. Okay, who on? I don't know what happened. Okay, it's here now. The first graph we are going to study is displacement time graph. This one is displacement against the time. The second graph we are going to study is velocity against the time. They are different, okay? And there are few important things based on the graph given, you need to know. Okay, the first one, we look at displacement time. Displacement is some like distance against the time. Okay, from displacement time graph, the most important information is when you calculate the gradient, it means you are finding the velocity. So remember that for this graph, gradient equal to velocity. Okay, why? Because when you look at a graph, gradient is displacement. Over here is displacement. Here is time. When you find gradient, when you take displacement divided by time. So displacement divided by time is exactly the velocity. Velocity is also displacement over time. So the conclusion is gradient of the graph is velocity. So this is the only information. From the displacement time graph, you can obtain the velocity by finding the gradient of the graph. When a gradient positive means positive velocity. When a gradient negative means negative velocity. Okay? Okay, all right, next graph. Okay, look at here. The second graph is velocity time graph. It's different already. Here is velocity. Velocity against the time. Okay, there are two important information here. The first one is gradient now become acceleration. Because gradient, you take here velocity divided by time. Over here is velocity, okay? Because this one is velocity divided by time. Velocity divided by time, change in velocity divided by time actually is acceleration. So remember now, for this graph, gradient is acceleration, okay? And one more thing is area under the graph. When you find the area under the graph, for example, here, triangle, you find the area of this triangle, so it is representing the displacement. So there are three information now. So remember this morning I'm going to study from this graph, displacement time, gradient is velocity. From velocity time graph, gradient is acceleration. And one more, area under the graph, under the line is displacement. So three important things are, please bear in your mind. You remember these three things, Okay, now we go back to the first one. We see example number 1 now. When I'm explaining, please copy, understand, copy. Then when you pass up your paper, no problem. You already have the solution. I wonder why someone can just pass up with blank paper. You just print up the paper blank, no answer copy there. And then you never think any effort to find the answer to copy, and then before you pass up. This shows that your attitude is very, very bad, for size 1, okay? You are not responsible, not concerned about your own study, okay? Okay, sorry for rest of the student. Actually, I only means towards a few students or a few of you never follow instruction, never finish work one. Then I have to scold the whole class. Okay. All right. Yeah, given this graph, so remember this displacement against a time graph. There are few sections of motion, A to B, B to C, C to D. Okay. So now the first question they ask us to find the velocity. Okay. Velocity of object from A to B, B to C, and C to D. Just find the velocity, right? You already know to find velocity, you must find gradient, okay? Gradient, okay? So the first part is AP, so you write like this lah. Velocity AP, so you write like that, okay? Velocity AP, write nicely. Handwriting, very important. Velocity of AP, so you find the gradient, this is positive, right? So 20 divided by 10. So over here 20, here is 10. So you get 2. Very simple. 2 meters per second is the velocity of section A to B, positive. So positive lah, 2 meters per second. Okay, the second one, BC, find velocity here. Okay, so you once again find gradient. Horizontal line, do we have any gradient for horizontal line? When the line going uphill, you have positive gradient. When it's going downhill, so you have negative gradient. This one going down, this one going up. But what about horizontal? A horizontal line will not have any gradient. So the gradient 0 lah. So meaning that BC velocity 0. There's no gradient, so the velocity is 0. Okay, 0 meter per second. It means that the object is resting here, rest for 20 seconds, not moving at all, resting at here. When the distance reached 20 meter already, so he stopped there, stop. When, okay, you see now, it start from here, moving away 0, 5, 10, 15, 20. When reach 20 meter, it stop, resting. Rest for 20 seconds. Because over here, the distance does not increase anymore. So it's meaning that the object actually stop moving here, stop moving, not moving out, resting. That's why velocity becomes 0. Okay. Okay, the last part, CD. Okay, just find the gradient now, but this gradient is negative, right? So 20 over 5, so you get 4. Okay, so the answer is -4. What is the meaning of velocity negative? Here, velocity positive. This one, velocity 0. Here, velocity negative. Velocity negative means what? Shara think. When velocity negative is meaning what? Shara?
Sorry, sir.
Velocity negative means what? What is the meaning when
Going backwards, sir.
Yes, correct. Going backward, moving in opposite direction. Yeah, Jiang, you are right. Jiang Zhensi, very good. Moving in opposite direction. So meaning that here starting point is A. Here is moving away, resting. And then here coming back to the starting point. Coming back now, moving opposite direction. Okay. Next part, they ask you to describe the motion. Okay. AP, what types of motion? BC, what types of motion? And CD, what types of motion? Types of motion. Okay. When talking about types of motion, mean you have to skip the term like constant velocity, increasing velocity, acceleration, increasing acceleration, such terms. Okay. So AP, what is the answer? What is the types of motion at AP?
Increasing of velocity.
Jiajin say increasing velocity.
No, I just try only.
Marcus, how do you think? A to B.
Yeah, increasing velocity. I also think it's increasing velocity.
Increasing. Okay, let me tell you. You see here, here is not velocity, Here is displacement. So from here to here doesn't mean that velocity increasing, because here is a distance, displacement. Only the displacement, only the distance increasing, moving away, getting away. So it means when the thing is moving, of course, the distance will get increasing from the starting point, isn't it? So actually here, we know that when you find the gradient, someone give answer, let me see. Increasing displacement, constant velocity. Yes, John, you are right. Actually, the answer is constant velocity. The velocity is constant because the gradient, the whole line, the gradient is constant, correct? Not constant gradient. The gradient is velocity. When the gradient is constant, mean you see, the gradient here, throughout the whole line, the gradient all same, isn't it? When the gradient same means velocity same. So it's constant velocity. It's because constant gradient. Gradient is a velocity. Understand? Okay, understand? Okay, what about BC? What about BC?
Zero velocity.
Yes, resting now. Zero velocity at rest. Okay. Resting at rest at zero velocity. Okay, not moving. And the last part is constant velocity, but in opposite direction. The gradient is the same, but negative is the same fixed gradient. So the constant velocity in opposite direction. Okay.
Also, teacher, this one in exam, we also need to label in opposite direction.
Yes. they ask you to describe the types of motion. You must say constant velocity. Okay, when it's negative, you say constant velocity in opposite direction lah. Okay. It's memang this one is constant velocity, the gradient is constant, right? But it is negative. Negative means we know that negative velocity is moving in opposite direction. Okay, like Sarah say, coming back. Okay, on the way back, correct not? Okay, okay, so this one done. Okay, now we move to the second graph we have just learned just now. And I'm sure some of you will confuse. No? Later on, after you see example 1, now we go to the different types of graph, velocity time graph, the second example, then you start to confuse. Okay, come, look at the question. So remember, bear in your mind, this graph is different from the graph you did just now. This is velocity against time. So here representing the velocity value 10, 20, this is getting faster. Velocity 10, here velocity 20, here show getting faster because this is velocity getting faster. Okay, so you have a few sections here. JK, K to L, L to M, M to P. Please add here, this is P, okay? P, P here, and this is N, this is O, okay? So please add here, this is P, And one more thing I want you to add this section 4 is not MN, is MP, okay? Please change the question to MP, okay? Yeah, and now let's answer the question one by one. Calculate the acceleration of the car between JK, KL, LM, MP. Now you are supposed to find the acceleration. We know that acceleration is actually the gradient. You find the gradient. In order to get the acceleration, you find gradient. Okay. Now you answer like this lah. Okay. JK, you write AJK. Acceleration for JK. So you just find the gradient is 20 divided by 10. So gradient you take y divided by x, isn't it? So 20 divided by 10, so you get 2 meters per second square. Okay. So that was acceleration for this part, positive 2 meters per second. When you can answer positive, gradient is positive means it's accelerating now. It's getting faster and faster. Okay. And KL, negative gradient. Negative going downhill is negative. So it's 10 divided by 10. No, here is 10. Here is 10. But you put negative. Negative 10 divided by 10, so you get negative 1. Negative for acceleration is so that is slowing down, is deceleration. So this is decelerate, this is accelerate, okay? It's correct. Here, memang is decelerate because you see the velocity start from 20, then end up with 10. It's slowing down. It's slowing down means decelerate. Here, the acceleration velocity start from 0, go to 10, then go to 20, getting faster. So it's accelerate. So for this one, acceleration. This one, negative answer, you get decelerate. Okay, what about LM? What happened at this section LM?
0.
Yes?
0. Is it 0?
0. I heard someone say 0. 0 what? What 0?
For the gradient.
Gradient 0. Yes. Gradient 0 means what?
Acceleration also 0.
Yes, very good. Okay, thank you very much, Jiajin. Jiajin, I know you are okay lah. The only thing is you are a little bit lazy to do your work. Correct? Not you never finish, you know.
Yeah, maybe I missed something.
I know. I know you because during the lesson, you are very responsive. You answer many questions. But when I only check your folder, some you never finish. Okay. So be more alert lah next time, Jiajin.
Okay, sir.
Okay. So here, gradient negative. Gradient negative means acceleration negative block. So negative acceleration. Sorry, 0 acceleration. 0. No gradient. Okay, Okay, here I want to remind you, all your listener, here acceleration 0, no. What about, do you think the object stop moving? Is it stop moving or not, or resting?
No.
No, not, the object still moving, moving with constant velocity. You see the velocity is constantly at 10. The mean is moving. Actually, the object is moving, moving, but velocity fixed as 10. That's why no acceleration. So don't be confused. Horizontal line, like this horizontal, is means gradient 0, acceleration 0, but velocity still there. Velocity is 10. Like previous graph, horizontal line, we say velocity 0. Stop moving, resting. So be careful. Okay. Next one is MP here. This one same. This one okay negative 10 divided by 5. Okay. So you get this negative gradient. So it's negative. Put negative yourself. 10 divided by 5. So you get negative 2. So here slowing down negative 2. Okay. Okay. What about PN? There's another additional I want you to find. What is the acceleration of PN and NP? NO, sorry, last two part, additional one. What is the acceleration P to N? Okay, I want to ask you all. From P to N, is getting faster or getting slower? From P to N.
Slower.
Slower. M to P memang getting slower. What about P to N?
Also slower.
Slower.
Backwards.
Okay, come let me explain. That's why here I say it's very tough, Actually, from P to N is getting faster. Because here you see velocity is negative. Negative only show that it is moving in opposite direction. She says start from 0, negative 1, negative 2, negative 5, negative 8, negative 10. Actually, it is getting faster, but it's in opposite direction. That means here it's getting faster. Actually, it's getting faster, but only in opposite direction. It's getting faster actually. Do you understand me or not, Marcus?
Yes.
It's getting faster because from 0, negative 2, negative 4, negative 6, negative 8, negative 10, it's getting faster, but it's in opposite direction now, correct not? So actually it's acceleration in opposite direction. Okay, now so you see the answer So it's still positive, consider positive, okay, 10 divided by 5, 10 divided by 5, so you get 2. So this acceleration is in opposite direction. Here it actually is accelerating, but it's in opposite direction. Okay, so the acceleration is in opposite direction. Okay, and finally, N to O, this one is slowing down. Here is slowing down. Start from negative 10, negative 5, end up 0. That means getting slower, but it's in opposite direction. So it's deceleration in opposite direction. So when this is deceleration, so you put negative value, okay? Negative 10 divided by 5, so it's negative 2 lah. Deceleration, but it's in opposite direction, okay? Can the last two part you can understand me or not?
Can.
Can Okay, copy down the answer, okay? Okay, next one. State the types of motion of the car. Types of motion. So like just now, law. How to describe NO? Please 1 point ask NO. Okay, NO means you are getting slower, but it's in opposite direction now because all your velocity here is negative, isn't it? Negative. Also here, all velocity is negative. Negative means moving in opposite direction. Only. The blue words are not here. Lo. Decelerate in opposite direction. Or you mean this part you don't understand? NO is decelerate because it's slowing down. -10, -5, 0 is slowing down. Okay, it's slowing down means must be decelerate, but the deceleration is in opposite direction. Okay, because all the movement below the graph here is they are moving in opposite direction. When negative velocity means move in opposite direction. Okay. Okay, we move on to the next one. Types of motion. JK, what types of motion? J to K.
Is it accelerating?
Yes, it's acceleration. But you need to add one more word in front of it because this is a straight line and then.
Constant acceleration.
Yes, correct. Let me check what linear Xuan go toward x-axis is slowing down. Yes, it's slowing down because it's going toward x-axis means like here no. -10, -5, 0 is actually slowing down, correct not? Lim understand no, go towards the x means start from -10, -5. The number getting smaller, correct not? Negative is opposite direction is slowing down. Okay, thank you. Understand already. Okay, so the JK is constant acceleration. It's acceleration, but it's constant. Straight line is constant. KL, this one is constant acceleration. KL answer is what?
Constant deceleration.
Yes, correct. Constant deceleration is constant deceleration. And LM, zero acceleration. This one you know already. Zero acceleration. Zero acceleration, you also can call it constant velocity. When the velocity is constant, no change in velocity means no acceleration. Zero acceleration. And the last one is what? MP. MP. All this lah. Now you see. So I make it smaller so that you can see the whole thing. Okay. Okay. MP, M to P, this one is constant deceleration now. Okay. And PN, here to here, constant acceleration in opposite direction. Okay. Okay. P to N, constant acceleration, but in opposite direction. Okay. Okay. Please copy down everything, all the solution. Okay.
Sir, NO.
Okay. MO, so is constant deceleration in opposite direction. It's deceleration, getting slower, but in opposite direction. Okay, got it or not?
Okay.
Okay. Yeah. So finish, everyone finish for size 1. Sorry, for size 1, for those who I named just now, okay, please improve your quality of works. You may be very good, I know, very good, very fast, can understand. But you need to come together with your work. So your work have to show same quality as your brain. Maybe you are very smart, but you have to smart brain must come together with quality works lah. Okay. Okay, for size 1. Don't get upset now because this morning my mood also not so good. So sometimes what I say direct one, So I hope you guys take it positively lah. Okay. Don't get angry over me. Okay, understand now for size 1? All right, come next question. Still the same question. We haven't finished now. The question is very long. Okay, and now we ask this one. Calculate the total displacement travel of the car. Now find total displacement. Okay. Total displacement for the car for the first 10 seconds when the car moves with uniform velocity and for the last 10 seconds. Okay. So you are asked to find total displacement for 3 sections. First 10 seconds when the car moves with uniform velocity and the last 10 seconds. Okay, you go back to see the graph. And also here, you see now, to find displacement, when you find area under the graph, so you find area. Okay, the first one is here. First 10 seconds is here, this part. So you find this area, triangle. Second part is constant velocity, so it's here, this part. Okay, find the area of this part. And the last one was what? He said last 10 seconds. Last 10 seconds is here from 35 to 45 seconds. So you find area of these 3 sections. First section is triangle. Second section, this is rectangle or maybe square. And third one is also triangle. So you find area of this, area of this, area of this. Okay, I go very fast. Area of this triangle, half times base times height. Base is 10, the height 20. Correct not? This one, rectangle. The length multiply the width. So 10 times 10. And the last triangle also, half times base times height. Base is 10, height is also 10. Don't need to negative height. The height is still 10. Okay, so you get this answer. Okay, straight away I show you the answer. So for the first part, the first 10 seconds, half times base times height. Base is 10, the height 20, the triangle. So you get 100 meters. The displacement is 100 meters. The second part, rectangle, 10 multiply 10. You see the graph line, 10 times 10, so also 100 meters. And last was the triangle also, half times base times height. The base is 10, over here is 10. The height is also 10. Height, we don't have negative height one. Okay, just take positive. 100. 100 divided by 2, you get 50. So we already calculated. Displacement here is 100. Displacement for C is also 100. Displacement for E is 50. So this one will be our answer. Understand? We run, understand or not?
Yes.
Yeah, okay. Joel, do you understand?
Okay.
Understand? Finding area only area of triangle, area of square, area of the most is trapezium only. Okay, now next part. Next is calculate the total displacement for the whole journey. Whole journey means you need to cover the whole graph. So you have 5 sections actually, A, B, C, D, and E. Out of 5, we already calculated 3. A, C, and E we calculated already. Now you need to go to B and D. Find the B and the D. My daddy can see so many messages come in. So all messages come in. Ask for this, ask for that, ask for this, data, that. Japatan, I know Japatan asks a lot of things every day. It seems that the teacher got nothing to do. Okay, so now how to find area of B and area of D? I just ignore it sometimes. Okay, all right. B is trapezium. Anyone can tell me what is the formula to calculate area of trapezium?
1/2 A plus B times height.
Yes, correct. Very good. 1 over 2a plus b times height. The a and b, what are the a and b? A and b, what are a and b in the formula? Huh? 1 over
Parallel
2.
punya.
What
Two
are the
parallel.
a and b? Parallel line. Yes, very good. The two parallel line. Parallel side. Jiang, very good. Jiang, thank you. Okay, the two parallel line, you look at the graph line is here, right? No, over here, lor, this is 20. This is 10, correct not? That means the two parallel lines are 20 plus 10. Then the height become here, lor. The height is also 10. Okay, Okay, now go to the solution. So you will get this answer. For section B, use a parallel trapezium formula. 1 over 2a plus b. A is 20, b is 10. The height is also 10. Okay, over here is 10, 20. Here is 10. The height is 10. So you get 150. And the last one, t, I think is okay. This is triangle, right? Half times base times height. So base is 5, the height is 10. So you get 25. And last, total displacement, right? Now you add up, then the last part you get minus. So why minus 50? Why? A 100, B 150, C 100, D 25, E 50, but the E be minus 50. Why minus pula? Why we don't add 50?
Because go in opposite direction.
Yeah, opposite direction, because this is negative one, you see? Negative. Okay, because you know why? Displacement is a vector quantity. It's a vector quantity, displacement. So the direction, when you calculating the displacement, right? The direction is very important. So meaning that we have to take into consideration the direction,
Teacher,
Because, yes,
so if you have to consider the direction, why in our number 3 when we are calculating the E, the displacement is 50, not negative 50. If it's negative 50, then it's in the opposite direction.
okay lah, can lah. You want to put negative here also okay, no?
Oh, okay, thanks.
Okay. It's okay lah, If you put here already, put negative, okay lah, it's okay lah, because it's supposed to be negative lah, because over here, right, the displacement. When you already put negative here, so here becomes still negative 50 lah, plus negative 50, okay? So just be careful lah. Next time when you find total displacement, right? The one above the graph, you add. The one below the graph, you minus. Okay? So minus, If you already put negative here, for example, like Joel asked us now, if here is already got negative, right? So what you need to do, you add up everything lah. Plus negative, so it become negative lah. Okay? Joel, understand?
Yes, sir.
Okay. So this is total displacement. Okay, what about next question? Total distance. Total distance travel. How to find total distance travel? Add up. Oh, yes, Lim Xing Yi is correct. Lim Si Yi. Because distance is scalar quantity. Direction not important. So you don't care anything, no? So you just add up. Add up. Even the 50, you go and add up. Okay? Don't minus, you add up. Distance is scalar quantity. Direction not taking into consideration. Okay, one just now minus 50, you get 325. When plus 50, you get what?
375.
You see lah, you all say 375, but you a calculator, you add what you get, you see?
425.
425 pula. So which one is correct? Now my question is minus 50, you get 325. Then plus 50 is supposed to be 375. But how come the answer shown in our calculator is 425?
Because the 3251 minus 50 already, so add up another 50 makes equal lah, like negative.
Because the 50 doesn't count.
Well, the 50 doesn't
negative.
count.
So if I plus 50, I only get 0. So I need to plus another 50 so I can get 50
Oh,
back.
okay lah, huh? Actually lah, for me, I will understand like this law. Between minus 50 and plus 50, actually the difference is 100, you know. Minus 50, then you plus 50, actually the difference is 100. Difference is 100. Between minus 50 plus 50, actually the gap become 100. That's why here you need to add 100, become 425. This is a wonder of mathematical law. It's like that one. You know, when you minus 50, then you add 50. Actually, the gap, the difference is 100. Just when you add 100, become 425. Okay, Hector, understand? Do you understand me or not, Hector?
Yes,
Chua?
yes, yes.
Okay, The rest are very quiet one. I think maybe some of you very sad. I scolded you just now. Don't keep in your heart now. Okay, what I said this morning. I know that sometimes, but sometimes I have to say it. What to do? Physics is hard. Jiang, no, physics not hard. For you, I think it's easy. Jiang, you are very good. But I see Jiang, lot of formula. Formula memang a lot, no? In physics, a lot of formula one, no? Okay? Because actually physics is very closely related to NMAX, additional max. There are certain topics you study in physics, you also study in physics one, okay? Linear motion, for example, lah. You also study in physics one, no? Ahmad say very positive. He said, take your time, okay? Well say, Ahmad, okay? Okay, come next. The last part, calculate the average velocity and average speed. Can you guys do it now? Calculate the average velocity and average speed. Can you all do it yourself now? Okay. By using the previous answer, okay, please find the average velocity and average speed. Okay, do it now. I give you 3 minutes to try. One more minute, class. Anyone got an answer? Can you share your answer? You got an answer, so you share. Please share your answer. Now, I see one of you give answer already. I want more answer. Jin Yong, your answer is for which part? Part A or part B? Jin Yong? Okay, Joel Lim give both answer. Jong Wei Hon give part 2 answer. You all can check the answer given by your friends. Velocity is 7.22. Speed is 9.44. Joel Lim give answer like that. Wei Hon give second part 9.44. Okay, you all can check the answer there. The answer are all correct. Yes, very good. Okay, well done. And Trute also correct. Okay, well done. Okay, come check your answer now. Okay. For average velocity, you must take displacement divided by time. So displacement was 325. Total time, you see the graph, total time 45 seconds. So 7.22 lah. So the second part is average speed. Speed, right? So you take total distance divided by total time. Distance was 425. Total time 45 seconds. So you get this answer lah. Average velocity 7.22. Average speed 9.44. Okay. Okay. Take down all the answer. Okay, class. Take down all the answer. Okay, class. For size 1. So I think this morning I have to stop here because so many things I have to check my handphone. Sometimes I don't want to be too late to respond. So I need to look into it. Okay. So okay, class. Okay, before I let you go, I need to take a pictures first. Okay, for size 1. Okay. This class now left 42% only. Yeah, one thing is this boy last week, there's only boy never pass up the folder. He passed up already. Very good. On the same day, that particular afternoon, he passed up. So, and I have checked his folder. He did finish the work lah. So, okay lah, Chan, where are you, Chan? Chan, are you here? Chan not here lah.
Yes.
Where are you? I never see your name, Chan. Are you here?
Yes, sir.
Oh, Chong Xuan. Oh, you never put your surname.
Oh, no.
Okay lah, So remember lah, next time pass up on time lah, Okay.
Okay.
Okay, so let's take one picture first for everyone okay. Now, my you don't need to on. You no need on camera I just see the name, so you can already. Okay. Okay, 1, 2, 3. 1, 2, 3. Okay. Okay, so thank you for size 1. Anything, anyone you want to ask me or not? Anything before I let you go for size 1? Anything to ask? Choi, you got anything to ask or not?
No.
Choi, don't keep in your heart what I say, Choi.
Okay.
Okay. And Joshua, where are you, Joshua?
Hi, sir.
Joshua, don't keep in your heart, understand?
Yes, no, sir. The
Okay.
one.
Okay, thank you.
You already got stress relief already.
1, 2, 4.
No
Huh?
nonsense. Okay.
Okay lah, Okay, thank you for size 1. So I see you again next week. Okay, bye-bye.
Bye-bye. Thank you,
Bye-bye.
sir.
Okay,
Yes,
bye-bye.
sir.
Yes, sir.
Thank you, sir.
Okay, bye-bye.